Today we're here to talk a little bit about some of the different rope constructions. We get asked this quite a lot by our customers. What are the different constructions that Marlow produce? What is the pros and cons of the different constructions? Why do we have such a range of different constructions? So we'll start at the very beginning with the oldest rope we've got here in the factory. This particular rope is 2,500 years old and is made out of papyrus. Now we don't make ropes quite like that anymore, certainly not in that material. But the construction is a three-strand. Three-strand ropes we do make. Just like the papyrus rope here, it's exactly the same construction. It consists of 3 strands twisted in one direction, then they're combined by twisting back in the other direction to create a stable rope that doesn't fall apart. This sort of construction lends itself to manual manufacturing. It can be made on a rope walk. It's very easy to do. It also lends itself to flexibility with different materials, which means if you're using natural materials, you can add or remove yarns to accommodate different yarn sizes to end up with a final rope construction size. So this construction has been around for thousands and thousands of years, and we still use it, but it's not our most common anymore, not these days. So after the 3-strand rope, we've got more modern machinery. Nowadays 3-strands are made on compound modern machines, but those machines opened up a whole world of other constructions that are possible. So the simplest one is the 8-strand construction, multi-plat, or sometimes octoplat is known as. This construction consists of 8 strands, 4 twisted in one direction, 4 twisted in the other direction, and then they're braided together on a machine that's got 8 carriers, 1 to carry each of the strands, and it's got 4 horn gears, and that produces a rope like this. This is the nylon multi-plat. It's used a lot for kinetic energy ropes. It's used for anchor warps. It's used as mooring lines. It's a construction that we've been making here for probably 60, 70 years. These first ropes that we're going to talk about are all single braids, so there's just one braiding operation involved in the manufacture. So this one is an 8-plat. It's still got 8 carriers, but this time that they're running on a machine with 8 horn gears. You can have 16 carriers running on 8 horn gears, but it makes a slightly different construction. So each of these plats passes over one and under one. This machine will also produce a 16-plat rope, which is this sample here. So these ropes are actually produced on the same type of machinery. These have a tendency to be a little bit flat in construction. So you can see it tends to flatten in use. This is very good for some things. It allows you to, for instance, accommodate smaller D to D ratios. We use the 8-plat and 16-plat construction in several places in our range. These particular products are what we call single braid aramids. They go into various aerospace applications. So you'll find them in parachutes, for instance. You'll find them in aircraft seating sometimes. You'll find them in all sorts of different places. We also use the 16-plat construction in our lash line, where its main advantage is that flattening, which allows it to cope with smaller D to D ratios. Unfortunately, that flattening means it's not ideal as a core, which is where 12-strand comes in. So the next common single braid construction, which is actually nowadays for us our most common single braid construction, is 12-strand. So this is a construction that's used for most of our cores. This particular rope is a Dyneema 12-strand. So this rope is made on a machine with 12 carriers and 6 horn gears. It leaves a smaller void in the middle than the 16-plat construction, which means it's less prone to flattening. It stays round, makes it ideal for a core. So most of our single braid ropes these days are 12-strand construction. That includes our winch line, it includes the D12 range, it includes the cores that go into our racing yacht ropes. It includes even the cores for double braid ropes. 12-strand is probably our most common single braid construction. So after the single braids, the constructions get a little bit more complicated with more than one braiding operation, the simplest of which is probably double braid, which is a braided core and then a braided cover just placed straight on top. What you end up with is a rope like this, which is 50% core, 50% cover. The core and the cover equally carry the load, so both of them contribute to the rope strength. So unlike the double braid, some of these other braided constructions have a construction which relies more on the core or the cover, so it's not necessarily equal core and cover. So this one, for instance, is a 16-plat cover with a very small Dyneema core in it. This one is an 8-plat cover. It's actually made on the same type of machinery. This time it has a polypropylene core. The main difference between them is that I want to highlight today is the texture. So the 16-plat construction is very smooth, whereas the 8-plat construction is quite knobbly. That texture is something that we can work with in order to make the ropes work with other hardware. So for instance, with ratchet blocks, with clutches and jammers, all those sort of things. Sometimes adding or taking away that texture can make the ropes work better in a certain application. We also produce ropes with high strength cores. These two are examples of that. So what we've got here is our D2 Club and our D2 Racing. The D2 Club has a 16-plat cover made on a 32 carrier machine. This one has a 12-strand Dyneema SK38 core. And then the D2 Racing, similar sort of size core, but this time it's a SK78 core, and it has a 24-plat cover. Now, the two covers, they work very similar. You can almost interchange them, but the 24-plat we find on balance is a little bit easier to splice, a little bit more popular with the race boats, whereas the 16-plat construction, a little bit easier to open up when doing the splicing, so it's easier to get the core out of. So these two samples, these two ropes are both ropes with high strength cores, polyester covers. This one is our D2 Club, this one is our D2 Racing. They work in a very similar way. The D2 Racing has a 24-plat cover though, the D2 Club has a 16-plat cover. These two ropes are made primarily for the leisure marine market, although they do find their way into other applications. This one is used a lot for upgrades to the polyester ropes, whereas this one is more for dedicated race boats. You'll find this on everything from weekend racer to Grand Prix boats. So then onto some different constructions. These ones are ropes that we use in our industrial access range. So these are industrial climbing ropes, static ropes. These ones are from the arboriculture range. Now the common factor with all of these ones is that they've got a braided cover, but the cores aren't braided. The cores themselves are parallel cores. So what we've got here is a static rope, nylon cover, 16-plat construction, and inside this is multiple little 3-strand cores. A little bit like these ropes, but much smaller. There's a runner's cores parallel inside. Whereas this one, you've got a 24-plat cover. This is our Vega, used for the arboriculture market, and the Gecko, which is a 16-plat cover. Now these two, get the end of them. These two, they both have the same type of core in them, but as you can see, as you look at the end of them, the Gecko has a much thicker cover compared to the Vega. So the Gecko is reliant on the strength of the cover in order to deliver its performance, whereas the Vega is much more reliant on the strength of its core, albeit both of them get a contribution from both core and cover. So as you can see, there's a great array of constructions. In fact, these are not all of the constructions that we can make. There are actually more. What we try and do is match the construction to the application to get the best blend of properties that we're looking for. Sometimes we get asked about how you can tell which construction is which. Now, one of the ways we work with here is we put markers into the ropes, and that helps us to count the plats. So if I were to take, for example, this rope, you just count the plats 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 between the markers. That tells me that it's got 12 plats going in one direction, so 12 going the other way. It's a 24-plat construction. As a general rule, as we increase the number of plats in the rope, the covers themselves get thinner. So it's a good example here is where a 16-plat is a much thicker cover than the 24-plat. These made on the 32 carrier machines are thinner again, and so on.